Hi everyone, Vigorous Rapscallion here with another quick tutorial video. This one I'm posting to answer a question asked by user Sunshine Scam. They just wanted to know how to make a door open after a delay. They asked for a 5-minute delay. We'll deal with a couple of different times. Sorry it's been a while since I posted a video. I've been busy with graduate school apps, but I've got a little time now. So we're going to start with this, but this is all stuff I've gone over in my other videos, just putting it together in a novel way. And after that I'm going to show you a new design element where I'm going to show you how to use a button to have multiple functions based on how long you push it, how many times you push it, that sort of thing. That's going to be part one of this video. Part two is going to be like basic escape room puzzles using the design element that I'm going to show at the end of this video. So without further ado, let's get started. Alright, so let's start by dealing with just the piston module, and then we'll deal with the button later. Now, if you've seen my other videos, you know I like to use a comparer chip. So we're just going to be building a sort of basic switching gate for the two velocities we need for our piston. Remember, we need a positive and a negative velocity as the two options for that, so that it'll move forwards or backwards. So that's why I like to use the comparer, because you can use the custom if-else case to set your two speeds there. So then we're going to need a variable to tell it what those speeds are going to be. I'm going to use 50, so we're going to need a 50 and a negative 50 for that. Start with 50. And then a negative 50 for the other. Great, and then we're also going to need something to compare against. So in the case that this is, oh, we should hook that up too. So these are our if-else cases here, and this is going to start in the false state. So we want that to be our negative value. And when it switches to the true state, that's when we want the piston to activate and move our door out of the way. But we need something to compare against in this system, so we're going to need another variable. I'm just going to be comparing against a 1, and you'll see how that works as the video goes on. So there we go. Now let's check our outputs here. It looks like we've got 0 coming out of the if case because it's not true right now, and 50 coming out of the else case because it is the else case. So those two values can't both be fed into our piston. We're going to need a combinator to handle them. Luckily, since when one case is true, the other outputs a 0, we can just put those into the same combinator, and that's going to work fine. And then now our output from here is still negative 50. We can take that over to our piston and make it the velocity if my hand stops swaying. Look at it go. There we go. Okay. Then we're also going to use this one here to keep our piston on. I like to just always keep my pistons on and deal with their velocities, because once they hit the extreme end of either angle or of either setting, they're just going to stop. So that keeps the system pretty simple. Obviously, for some applications you are going to want to turn it on and off, but for this one we're just going to deal with the velocity. So that's a basic switching gate for our piston. That's all set up. Let's deal with the button and the timer next. Okay, so what do we want to happen with this button? We want to press it. We want there to be a 5-minute delay. We're going to make it less for the example, but I will show the 5 minutes at the end. You want a 5-minute delay, and then you want this door to open. So we need a 1 coming into this system after the 5 minutes. What chip do we want to use for the delay? We've got a delay chip and a timer chip. The delay chip is handy because it can deal with a ping. It only needs a ping from our button to start counting down, whereas the timer needs a constant input. However, the timer does have a time expired option, which I like using it for things like this. I mean, if you had this in a game, you might want to have like a 10-second warning or something at the end of the timer. So I like to use the timer even though it's a little more complicated to set up. Okay, we're going to need another variable to handle our countdown time and all of that. Let's start with 10 seconds. So as you know, these deal with tenths of a second, so we're really going to put in 100. There we go. I was standing sideways, that's why my hand wasn't tracking. Okay. And let's see here. So that's our time, and then we can't just connect this button straight to the on-off setting here, because once again it'll only ping it, only count down by 1/10 of a second each time. We need that to stay on. We're going to use a combinator for that again. Just one set up to hold a single value. So we're going to loop that back on itself so it holds any value that comes into it. Every time this iterates, it'll go up by 1. But as long as there's anything besides 1 coming into that node, it's going to keep counting down, so that's handy. Then we're going to get an output from the timer expired ping, but that's also just going to be a ping. That won't keep our piston over here running. It's just going to move for a tenth of a second and then stop, so we're going to need another combinator to hold that value. Put that one there. And same thing, we just loop it back. Then we take this, put it up there, and when this expires, we're also going to want to reset this system here so that it doesn't just reset and count down again and mess things up later on. So that's the basic setup. We don't have a way to reset this system yet, but that's what I'll be dealing with next. Let's just see if the basic setup works if the door opens after 10 seconds when I press the button. Man, 10 seconds is a long time. Come on, buddy. Oh, I forgot to hook that part up. There we go. Okay, it does work. That moves it far enough. We can walk into the tree now. Hooray, I'm in a tree. All right. So, that seems to work, but we have no way to reset this system, and I could just make another button that does a chain of resets. If we reset that guy over there, this whole thing's just going to go back. I'll prove that real quick, just so you can see it in action. And so we can reset our system. There we go. So since that's 0 now, this is now false again, which put it into its negative velocity, which moved the door back into place. So next we want to deal with the reset function, which, like I said, I don't want to just use another button. Instead, we're going to make this button multi-purpose. So what we're going to do is we're going to have one output going to there, that's the win button pushed, but we're also going to have a option for win button held. And to reset the system, you're going to hold the button down for 5 minutes. For 5 seconds. So let's see how to set that up next. Okay, so what needs to happen for this system to reset? Well, that combinator's got to have no value held in it so that this will go back to its negative value and the door will close again. And this combinator also can't hold a value because if it does have a value besides 1, the timer's just going to keep going. That's going to reset the whole system. After 10 seconds, the door's just going to open back up again. Now, problem is we already have something hooked up to the reset option for that combinator. Luckily, we can just use a combinator as a signal conflator as we did up there, exact same setup. But this time, we're going to take what we already have resetting it and make that one of the options. And then we're going to take the daisy chain reset from our other combinator. So if either of these things happen, that's going to reset that combinator. This one will only be reset in the event that we hold our button down for 5 seconds. Let's deal with that next. So we need a comparer, obviously, to compare against the value of how long we've had that button pressed down. And since the while button pressed option is just going to be a constant stream of 1s, we can't just compare against a 1. We're going to need another combinator set up to hold values. There we go. There we go. Great. So then what do we want to compare against? Well, we're going to need probably a 50, which I set up earlier over here. You can see that's 50. So that's 50 tenths of a second, or 5 seconds. So if we hold this down for 5 seconds, what do we want to happen? We want to trigger this whole chain of resetting so that all of these combinators in that timer reset. But now we still have a problem. The value of the wall button held is still going to be in there. So if it's over 50, you're never going to be able to reset again. If it's under 50, then it's just going to take less time to reset the system. That would be very confusing for the user. So we need a way to reset this. A really easy way to do this is to just use the win button is released. So then even if they don't hold it down for the full 5 seconds, as soon as they take their hand off, that countdown restarts. It will still take 5 seconds to reset the system. So let's see if it works. We're going to start with just allowing the system to do its thing and then resetting it. Then we'll see what happens if we interrupt it, and then I will show you how to set it to 5 minutes when we're done with all that. Okay, it should be opening up real soon. There we go. Now, this is a little annoying. While I'm holding it, this countdown is going to go down, but if you have that hooked up to a sign, it would be noticeable. There are ways around that, but I'm not going to deal with that in this video. So let's go ahead and see if we can reset it by holding this down for 5 seconds. There we go. And when I take my hand off the button, it should reset that combinator. So let's take a look there. Now let's try this. You hold it down, see the value goes up. Oops. Accidentally let go of it. This is why the wall button held option has some issues. But let's see here. See, it's going up, and then it'll continue going up past 50 indefinitely, but as soon as I take my hand off, it's back to 0. Okay, great, but can it interrupt the system? Let's say that you wanted to stop the timer in the middle. Let's deal with that next. So let's start it. Countdown's going. Now let's press down and see what happens. There we go. So you can also use it to interrupt the timer in the middle. So last thing we're going to do is we're going to make this take 5 minutes. I am not going to show it opening after 5 minutes. I have other things to do today, and I cannot stand here waiting for a door to open. So I'm going to set it, but we're not going to demo it. So to set the time, just going to go here. And so how long is 5 minutes going to be? Well, that's going to be 300 seconds, or 3,000 tenths of a second. And now we've got 300 seconds, which is 5 minutes. You'll see it is counting down a second per digit there. So this will open eventually, but like I said, I'm not going to show that in the video. Next, I'm going to be taking the same idea and showing you how to do some basic escape room puzzles, how to conflate things, though, so that a player needs to do, say, multiple things before a door will open, so you could have timers with bonus options. So if you're interested in making escape rooms, check out that video. That should be up in the next couple days. But for now, as always, thanks for watching. Have a nice day.